This video is on Boyle's law, which is one of the individual gas laws. And this is the way to solve problems with Boyle's law using the relationship and not just the equation. So variables in Boyle's law are pressure and volume. So as one changes the other, it changes the other, affects the other. So that means the constants for our gas are moles and temperature. So you won't see moles or temperature, or you won't include them in any of your equations or problems or any of the math calculations. So the equation, even though this is the relationship way, we should still be aware of this, is that pressure times volume will equal what we call a constant, and we usually write a K for that. So I'm going to label this as a constant, meaning pressure times volume of a gas will always equal the same value, which is where we get our equation from, which is any pressure and volume, so I'm going to label these both 1, will equal any other pressure times volume, and I'm going to label these both 2. So what's important for us in this video is the relationship. And between pressure and volume, as the pressure increases, that means the volume decreases. And vice versa. So if the volume increases, the pressure decreases. So sometimes a shorthand way of writing this would be pressure increases, so I'm going to draw an up arrow. Volume decreases, so I'm going to draw a down arrow. So when they are opposites like this, we call this an inverse relationship. And you may have used this term or seen this in math class. So inverse opposites. So let's go through a problem here. So the problem says a sample of gas has a volume of 460 milliliters. So what I'm going to do is I'm going to underline all of my values, all the things that are going to be important for me. So 460 milliliters is my volume. When measured at 35 degrees Celsius, there's a temperature, and 740 millimeters of mercury. So there is a pressure. So we have to understand our units to make sure we know what variable it's referring to. So then it says what volume in milliliters, so this is my question mark, or I could just label it volume too, will the gas occupy at the same temperature and 175 millimeters of mercury. So I've got a pressure. So here's what I can do. I can first eliminate anything that stays the same, anything that doesn't change. That's, as I go back up here, those are our constants. So notice moles wasn't even mentioned because they're constant, doesn't matter. Temperature, it says it's the same temperature. So this number means nothing to me for this problem. All right, so what I care about are my volume and my pressure. So I like to write out these in a little table so I have a very clear layout of what I'm working with. All right, so my first volume, it says, is 460 milliliters. So 460 milliliters. And my first pressure is 740. So these two go together, 740 millimeters of mercury. Okay, so then it says what volume, so I want to know what the volume changes to. Well, my pressure changes to 175 millimeters of mercury. All right, so what I can do now is I can use my pressure, because I have both values, as a conversion factor. So I start off with what I don't know my other part for. So I have 460 milliliters. And I'm going to use that pressure as a conversion factor. So to figure this out, I have to look at the relationship. So I can see here that the pressure decreases. 740 to 175 goes down. So if this is an inverse relationship, if the pressure decreases, the volume should increase. So our volume, our answer, is going to be bigger than 460. So when I figure out my conversion factor, I have two choices. I can do 740 over 175, or I can do 175 over 740. And I have to think about what's going to make my volume, my 460, increase. Well, a number that's bigger than 1, a fraction that's bigger than 1. This is the conversion factor I'm going to want to use. Another way to think about it is if I want my value to go up, I'm always going to put the bigger value on top. 740 is bigger than 175. So I'll write in 740 millimeters of mercury. Oops. And on the bottom, 175 millimeters of mercury. And my millimeters of mercury divide out, which gives me a unit for milliliters as my answer. And when you plug this in your calculator, you should get 1,945, but that is too many sig digs. And I can only have 3, so I'm going to round that to, we have a couple ways to write that, 1,950 milliliters, or 1.95 times 10 to the third milliliters.